Hello there. So last week I was working on simple sort of data pipeline, a little language that takes functions and pushes them through a pipeline. And I struggled a bit last week with the interpreter, not with the interpreter, sorry, with the parser, trying to get it to parse command arguments properly, in particular parsing string literals. But got it working just enough, and then I built a very simple interpreter, which just basically ran the commands that were in the pipeline and then passed the result through to the next command. And that was all cool, but I ended up with something that takes text or strings and pushes it into another function which takes strings and so on throughout the pipeline. So what I'm interested in doing tonight is looking at what happens if you add another type. So for example, the pipeline I built last week took UUIDs as a string and then stripped out, what does it do? It stripped out the dashes from there. The thing I'm interested in doing today, I think, is adding another source function, like at the start of the pipeline, that emits dates, which would be a different type, or maybe time is a different type, and seeing how that affects the way in which we build the interpreter. We might put some type checking in place. I don't actually know how it's going to work. I don't really understand how I'm going to have functions which take different types, because they're typed in Haskell, but when I'm running the pipeline, they won't be typed. So I'll need to think about that a little bit. So yeah, that's the plan. Let's get started. But actually, before I get started in adding a new type, what I'd quite like to do is write a main function so you can actually run this thing from the command line. Because I think last week I wrote the spec, what's in parser spec, sorry, the interpreter spec, where you give it a sort of pre-tokenized version of the input pipeline. I also have the parser spec, which takes an input string and turns it into this tokenized version. So it's just really putting those together in the main function where we read from standard in. Do we read from standard in? I think so. We'll read from standard in, and then we will parse it and then run it through the interpreter. That's the plan. So we have this thing which prints out hello Haskell. Just make sure it works actually before I change anything. Yep, it says hello Haskell. It's very exciting. So I want to change this to be interact and then something like run pipeline. Interact is not in the scope. Can you put it in for me? Okay, the text IO interact. That's probably the one I want. Okay. And then we need something called, run pipeline. It's going to go text to text. And then run pipeline. Given some input string. Do I need this? I'll write it out long form and turn to point 3 in a second, I think. Because what we're going to do is we're going to run the parser. Is it called parse? Yes. So we're going to parse it. Let's pull it in. And that's going to give us back a list of tokens. And then in theory, we can feed it into the interpreter. So we called it eval. Let's get rid of the S, I don't need it as an argument. And import that. Okay. So the parser returns something of type. Okay. So it's either an error or it's either an error or it's going to be the value that we want. Okay. So we could just do this. But now the whole result here is going to be either the error or the result. And we need to turn that, we need to handle that basically. So we can say, case this of, so we got left and some kind of error. and we'll just show that error. And if we get right, some kind of result, I guess we just show that as well. Okay, and then that should be enough. Then we say compile run. Oh, no prompt. Okay, so we say UID, and that's not the syntax. The syntax is that, and we say replace. Not replace. That's not the function we have strip. I think it is, and that should be it. And we get an error. Good. Maybe we want to format this error a bit better, but trivial error 5. Good. What's the actual error in here? I'm not sure I can see exactly where the error is in all of this. Okay, have a quick look at the parser spec. Should be able to parse this. This comes through okay. Oh, it might be the end of file thing. Okay, so yeah, new line. I think it might be new line. So it handles new lines. And new lines. So we will say this with a new line. Let's just throw in more space for fun. And we expect this thing. This is no longer a pipe, it's just a call. Okay. Yep, so now it gets upset because of the new line, I guess. Okay, so in the parser, when we say parse, we parse expression, and the expression parser looks for end of file. So we could say just space. Okay, everything passed that time. Cool. So now actually I can try compile run again. And it was UID, no, not that, pipe through strip dash. There we go. Okay, cool. So it now works. So could we simplify this a little bit? We could say UID pipe through strip. I'm going to change my quotation marks so I can use double quotes inside. And we'll pipe that through compile run. There we go. Okay, cool. So now I have a basic main function, so I can test this by actually running stuff through the interpreter. Okay, let me just quickly commit that. So this is add main function to run the pipeline. Okay, so now we have that, we can start to look at another function, which is going to be dates, I guess. So in my plan, oops. So that's all we have so far. What I'm interested in saying is maybe just say current time. and we'll pass it into, what do we do at the current time? Maybe we pull the date out of it. Yeah, I mean, I guess that's the thing I could do with times and dates. So that should be fine, I guess. But if you said something like current time and you put it into strip, that should blow up because time is not a string. So I would say should error, and it should be fine. Okay, so we go back to the interpreter itself. You can see here that when we evaluate, we take an expression, we take the previous text value, and we put it into the next text value. So what I actually want to do, I think, well, let's do this bit by bit actually. So maybe let's start with, why did that change it to 2 spaces? I'm sorry, I want to start with just adding some new functions. So we'll have a date, and we will have like a current time and a to date. Let's add those in as functions. Do we have a test for interpreter? We do. So describe. Describe commands. It handles current time. Current time is interesting because this is also an effect. In the sense that it needs to run under IO. So to get the current time, I would need to change the whole pipeline to be IO text. Maybe that's okay. It's going to break a lot of stuff. So eval call current time. I don't know what the current time is. That's a bit annoying. So I can't say should be the particular time. I can't say it should be now because now moves. So what could we do? Hey Thomas, let's not write a function called current time. Let's write something easier than that. So I'm going to, instead of having current time, let's say parse time. So parse time, and I'm going to give it a simple argument which can be something like 2023 dash, what's the date today? 04-06 T. How do times work? And current time here is 21 14 00.00. Shall I say Z? That's a bit of a lie because we're actually plus 001. So we plus 01:00. Okay, how do times work in Haskell? Let me search for time. I parse it from here. This is formatting, unique cell parsing. So parse time M. Knowingly it takes false as first argument anyway. Locale format string and input string. Has it got any built-in times? Just jump back for a second. There should be a ISO 8601. So has this got a formatter? No. It's got a built-in formatter. Just looking for something that gives me the default for parsing, the default parse string. But I can't see there. Con formats. Here we go. UTC time. It's not quite the one I want because that should be Z. The zoned time is the one I've written. Okay. So I can go where we time, data time format this zoned time. So I guess in Cabal, I'll need to include time in my library. So let that catch up. And this has got stuck. So just 1 second. Okay. So we can say something like let expected time, and this is going to be I do it on the formatter. Sorry, the parser, not the formatter. Parse time M. The M suggests it's monadic. There's a couple of examples. Drop in here. So I try to do. I'm going to say this. Okay, and this should be expected time. And what's my error here? I'm not closing my string properly. That's what's happening. Why did I skip these? Okay. So describe comes from hspec. There's time M. I need to import data.time.format parse time M. So not data time format. Data time format. Okay. So what's this problem? I've imported time in the library. I causing to import it in the test. Let's give that a second to reload. Is it done? Should be done. So what's the problem now? Can load module test at HSpec. Let me just restart the LSP server. Okay, getting back to where we were anyway. So parse time image should be able to import now. Yep. And default time locale can import as well. Okay, and we return text, and it doesn't expect text to come back. Okay, so this thing, I was going to pull in a special format, which was something I've forgotten. Was it zoned time or something? Zoned time. I'm copying this because I've forgotten how I mapped capital Z on my keyboard. It's a common problem. I can import from data time. I cannot import from data time. Okay, this comes in as so it gives back a zone time, expects a character or a list of characters, a string. So how do you actually use this? Oh, I use this, I think. Is that right? Takes a string and returns, no, that's parsing the format. Whereas this will take the format, return a string. It was ISO, forgotten what it was now. That. Okay. We want to make our strings match up. I'll just copy this. It'd be quite nice if I didn't parse it in here. I actually just created the time directly, but anyway, I've imported this now. So I'm going to say this should be, for now, I'm going to say it should be the same as show expected time, just to get rid of the type error. You cannot show expected time. No, it's ambiguous type variables. Okay, so parse time of type. I'm going to go and find an example again, but it should be, oh, missed. Where are my types? It's still parsing. Maybe day. And we actually want maybe something else. Maybe local time. Let me try maybe local time. Okay. What's the problem now? So show goes from T, which is an ISO 8601, to a string. So I was expecting another argument. Zone time is the wrong argument there. Let me just get rid of zone time from here. I think it's imported the wrong zoned time. So here we can add it to, no. If I go back to here, can I just construct it somehow? There's some kind of constructor that will let me just build a time. Time to days. No. I kind of want to give it like the year, month, day, and then the time as separate arguments. But I'm not finding that. Anything in here that lets me do it? No. Okay. I go back to parsing it. So when I was parsing it with this, zoned time is in time format ISO 8601, and allocate an instance on zoned time. So in theory, I can import it from data time, I think. Brackets there. Okay, so the problem now is data time format, blah, blah, blah. No instance time zone to zoned time. Just want to parse a thing. Just type the string in by hand. So can we do go back to here. The example I had was year, month, day. Unfortunately, it's only this format time, and it's got present Z. So it's going to be percent y, percent m, percent d, capital T, percent r, I'm guessing. H, sorry, for r. Percent m, these will be colons. Percent s. And then percent z. So we go back to here by format time. So what we're doing is format time. Hours, minutes, lowercase s for seconds. But it might be ES. I could just get rid of the decimal point, actually. I don't need that. And there's lowercase s here. And I'm going to say it must work. Okay. So let me just clean this up a bit. Okay, so if I run this test, it should fail for a number of reasons. Oh, because I wrote undefined for things it doesn't know about. So I don't even know what it's failing to match. So in here, we can say call built in, and it was parse time. Yep. Parse time and some x, and we'll just show x. Oh, const x, because there's another argument coming into this, which is the previous value. But if I add an extra parameter here for this case, I have to add it everywhere. So const x will just throw away whatever I'm passing in and return this time. Okay, so I run the test again. It should not fail for that reason, but they shouldn't match. Pattern match fail. Okay, that's not what I expected. This has failed, so I cannot parse the time properly. So year, month, day, t, r, minute, seconds, and z. I might need the e in front of this. I can't remember. No, still failing. Okay. Compile REPL. Import data.time. Paste. Nothing. Okay. Let's start from simpler cases and build it up then. So that one works. And then we put in T 21 35. And then here we can say literal T and then %r:% m. capital M. So that one works. And then 0, 0. So we'll say %s, still working. Just check by putting some value in here. Oh, it ignores the S. That's interesting. And then we had present Z. And that doesn't work. So we should here be able to say plus 01 colon 00. Oh, that does work. So percent YMDT percent H colon percent. I'm missing a colon. That's what it is. Wow. Make it a bit bigger. Okay, cool. Getting there. And that's not bad actually. So this is me showing the time, and this is it returning the original string that I passed in. Okay. So now I'm going to get rid of the show part here, and then I'm going to break everything because it's returning text from calling eval. And in fact, this is now an expected time. So with an interpreter, instead of returning text, what I actually want to return is a value. Let's call it that, because I can't think of a better name right now. So value is either going to be, can I use text? I probably can't use text because that's already been used for something. But I could say value text, and that contains a text. Or I might twirl it around a bit so it reads better. So it's actually going to be a text value. Or it's going to be a time value, which is of type local time. Local time. And we can import that. Okay. So now what we want to do is go from, this is going to be a nightmare now, from value to value. Okay, and now we can't just call it with an empty string, we need to call it empty value. So actually this is going to become maybe value, because at the beginning of the pipeline there's not going to be any previous value, but it will always return some value. So we'll pass in nothing. Okay, and it's going to return a value. Cool, and now everything is very broken, so this should now return a value. Okay, and go is also going to return a value. And actually it's going to be maybe a value. And okay, so now down here, okay, so we call it where C is the call that we're going to make. So we got here. So we got go. Expression is either going to be a pipe or arguments. Then x in this case is going to be the possibly a value. So we run expressions, passing in the result of running a call. Now when we have a call, we return something with type value, but when we recurse into go, we want maybe a value. So it's going to be just this. Okay, get closer. Now, what do we want to do? In here, when we call UID, get maybe a value, and actually calling const is fine. But I'm going to start matching these things. So UID expects to be called nothing. This expects to be called just B. This expects to be called nothing. And this does not care what's called this. Right. Get closer. So now we have this thing where, in fact, it's not just B, it's just text value of B. Okay, we can't call const of some string, we have to call it const of text value. Something can match type value. Oh, we don't need const anymore. Right, so it's just going to be a text value. This is going to return some text, so it's going to be a text value. It's not a const, but it's going to be a time value. And it's going to be some kind of error. Right, so could match. Okay, so this comes in as a string, so now we actually need to parse it. We're going to return time value. So in here we can say case. We don't need to do actually. Case parse time m of it's something like true, and then the time format, default local time, and then the string, and then the x. So if that comes back as nothing, then we need to do something, and let's just throw an error for now. Bad time format. Whereas, actually I'm not going to throw because we're not running under either type. We're going to just error that. Whereas if it's just some value, then we return time value v. Okay, and then now import these things. And this one. Okay. And x. So what's the problem here? Expects a string and it's actually text, so it should be theta unpack x. Okay, and then we want to here say deriving stock show in the EQ. Deriving strategies. So in common, deriving strategies. The same if I type with it somehow. Don't know. Okay, that at least has gone away. So the problem here actually was nothing to do with deriving show and equal. There was a fact that I can't return error. So what I'm actually going to do, two things. First of all, I'm going to say it's a text value, which is the wrong answer. But it'll make it go away so I can start to test my date thing. Really, this should be either some kind of error or a value, but I'll come back and do that in a second. Well, not in a second, probably next week. Okay, should be expected time, and not going to line up, right? Because it's a value and it expects a local time. So in the spec, I should say time value and export that. So I'm confused as to why there's no error. Data construction not scope. Yeah, that's what I thought. My LSP server's gone awry. That's a bit annoying. Okay, in the interpreter we will export structures for values. This is not a good sign. The LSP server's gone very broken. Let me write it in by hand. We want time value I'm just going to add time values to import list. I thought I did that. Because it hasn't saved them properly because everything is broken. Cabal build. Is this happy? It is. Okay, so it's the LSP server itself, which has gone awry. The errors instantly. Spelling suggestions from plan. That's really not helpful. Okay. Let me just get rid of the language. Okay, it's just because the number of errors was confusing me, so now I can trust it some more. LSP, start the LSP server. Will it start properly? Okay, cool. It's now happy again, I guess, because it's now complaining. Right. Overloaded strings. Let's not go there. Let me just put local text. Oops. Not local text, it's text value. And okay, now it's unhappy about brackets. And then down here, it should also be text value. There's a type class called isString. I think it's called isString. And when you have overloaded strings in place, when the type that it expects here is not string, it tries to work out what the type is. In this case, eval returns a value, and then it tries to call isString or fromString or something like that. It uses a type class to convert this into a value. So I could implement that on the value type, so that you could say just a normal string like this, and it would convert it into a text value for you. So you wouldn't have to specify text value here. But I think that would be problematic for time value. So let's not go there for now. First of all, let's see if the tests pass. One failure. Okay, unquote exception. Error call, bad time format. Interesting. Is it that? Yes, it is. Okay. Right. Actually, I might try the thing. So there's something like deriving new type is string. And then I'll need generalized new type deriving. And nope, I can't do it because it's not a new type, it's a data. Okay. So you'd say instance is string value where from string s is text value s. So you just say this, can we? But we expect to be text, so it's t.pack. Okay, and then back here, can we drop out text value? Yes, we can. Look at that. Amazing stuff. Okay. Cool. So what have we got? We now have another type, a second type, which parses the time. And so we go back to main. Main should be completely broken now. Oh no, because I called show on this anyway, so it should be good. So, does it work? Does it, the old thing still work? Yes, it does, but it shows it as text value. Not the end of the world. Okay. But if we said something like parse time, and say 2022, 0406, so last year, 21 55 00 plus 01:00. Doesn't like it. Bad time format. I've got to put T in there. There we go. We get a time value back. Okay, cool. So we now have something that takes times as well as something that takes strings. So I think I might stop at this point because almost up to 1 hour. What I'll try and look at next week is, I guess, a couple of things we could look at. One is, instead of returning value, and in particular from run, instead of returning value, we'll handle errors properly. So we'll say either some error type or a value. And we'll write another function which takes time, produces some output. We can add some error case here when we don't match the expected clauses here. And the other thing we can look at is type checking. We can say parse time expects a particular type, I guess a string, and it produces. Sorry, the argument is always a string. You say parse time doesn't take anything extra, so there's nothing previous to it in the pipeline, and it produces a time value. New UID doesn't take anything but produces a text value, and strip takes a text value and produces another text value. And then the type checker can say, do the types line up in the pipeline? So I might look at that as well. I kind of need both things. I'll maybe start with the error handling because the type checker is also going to return an error. So let's maybe put that in place. Cool. So that's my plan for next week. Thanks for watching along. And yeah, I hope that was better than watching me struggle with megaparsec for 50 minutes. Cool. Let me just unstage plan, commit this. And this is adds time value type. Show stream. Cool. Hopefully see you next week. Thanks for watching.